safe and doing well. I would like firstly to introduce myself before I start my presentation. My name is Hala Younis, a civil engineering lecturer and a PhD student at Hala University. The topic of my presentation today is part of a research project at Hala University. The topic is a computational parametric study on strengthening timber member. The main key points that I will discuss today in my presentation are introduction to the construction material that I am investigating on, problem statement, significance of the study, the objectives of the study, methodology used, result discussion, and end up with conclusion. So as we all know that the urban population is growing rapidly, and with such increases to population, the living spaces will be very limited and unsustainable. Therefore, a significant attention is required at this stage for this urban development. The solution for this urban growing is found in large buildings. However, most of these buildings are made of concrete and steel. And the problem of those materials is that the production of concrete and steel emits huge volumes of carbon dioxide, which significantly needs to be reduced. Therefore, we need to find green and sustainable ways to build these large buildings using eco-friendly materials only in order to produce a healthy living spaces for our community. Building with timber is found to be a very sustainable solution to be used as structural material in the large buildings. And recently it has become used widely around the world due to its special characteristics. These characteristics are environmentally friendly. And as we all know that timber is the only renewable construction resources, it generates less construction waste, it has less greenhouse gas emission, and the most importantly, timber can absorb CO2 from atmosphere, which can effectively reduce the carbon dioxide from atmosphere. Also, it is cost effective. Building with timber required less on-site workforce, means less labor, locally available. It requires less construction time, less construction equipment used, especially the heavy equipment, and building with timber is fast delivery. All these advantages make the option of building with timber is cost effective. In terms of good impact on community, timber has a good impact on community due to its special character of observing the carbon dioxide from atmosphere, and also good impact on workers and employees, as well as it is light material, and in most cases it is not require, or maybe less require heavy equipment and machines, and less lifting requirement compared to building with other materials like steel and concrete. Other advantages like easy to handle and construct, easy to transport to site. All these advantages make building with timber is sustainable. Timber is commonly used as a structural material for small, lightweight buildings and short-span bridges. Use of timber as building material has increased over decades through introduction of engineered wood products, such as LVL, laminated veneer lumber, glulam timber, cross-laminated timber, plywood, and others. Building with timber is not something new. It's not a new method or material. It has been an important source in building and construction in building and construction industry for decades. And due to its strength and serviceability characteristics, there are a number of ancient buildings made of timber still strong and standing until today, as we can see in this figure. So we have this building, Bethlehem House, that was built in 1267. Jokhang Temple was built in 1800. Kintai Bridge was built in 1670. And the Lekki building was built in 1900. All those old buildings are still strong and standing until today. So from the figure and all those buildings, timber is commonly, we can see that timber is commonly used as a structural material for small buildings and short-span bridges since decades back, as I said before. And moving from ancient buildings to 21st century, where we can see the development of using timber in mid and high-rise building as shown in the figure. In recent time, timber has gained popularity in mid and high-rise buildings, building of 5 to 10 stories, but the aim is to build higher, okay, using timber only, like 15, 20 stories. Architects and engineers are finding structural timber beams with long span, like longer than 7 meters, and supporting residential loads of, for example, 1.5 kilopascal are serviceable enough within 300 millimeter depth floor space. Such deficiency result in replacing timber framing option with a steel member, as shown in this picture. Or the other solution, double the depth of the timber beam. And this result in losing the economic and sustainable advantages. Therefore, this study is focused on finding an economical reinforcement method in order to strengthen timber structural members and increase the load carrying capacity of the structural member. The main objectives of this study are to reinforce timber structural member, to replace commonly used material like steel and concrete, to increase the load carrying capacity of timber member, conduct a parametric study to determine effective approach to reinforce timber member. The methodology used in this study is summarized in 3 stages. First stage, finding the best reinforcement materials. The second stage is finding the best implementation method of reinforcement. And the third stage is conduct computer modeling based on the result of stage 1 and stage 2 in order to find the best economical approach to reinforce timber structural member. So the first stage, finding the best reinforcement material. A number of reinforcement materials have investigated in order to find what is the best reinforcement material to reinforce timber member. The result of the investigation showed that there are a number of reinforcement materials used to reinforce timber members, such as metallic materials, This material has reported a noticeable strength improvement in timber structural member. However, due to many reasons such as corrosion, adding extra weight to structural framing, expensive material, and it is required high-skilled people to install this material. Therefore, the use of this material has been reduced. The second material found as a reinforcement material is using hardwood compressed duals. Using this reinforcement material did not show significant improvement in timber framing. Therefore, further investigation was conducted, and I found that there is another material used as a reinforcement material, which is fiber reinforcement polymer composite materials. This material has showed a significant strength improvement to timber members. And recently, using this material as a reinforcement material has increased due to its special characteristics, such as strong, light, available, cost-effective, easy to use, and install to the member. Therefore, based on this result of investigation, the reinforcement material that will be used in this study is fiber reinforcement polymer composite material. After this stage, we need now to move to stage number 2. In stage number 2, finding the best implementation method of reinforcement. For this stage, many approaches conducted to reinforce timber member have reviewed in order to assess the influence of applying the fiber reinforcement material to timber members. And the most important approaches are summarized in this figure, starting from test number 1 to test number 12. This stage was conducted by reviewing various installation method of composite material to timber member. The figure shows the various also strengthening approaches applied to timber structural member, indicating the type of timber, such as engineered timber, LVL, and glulam. Also using wood products, such as natural wood, such as pine wood, fir, and oak wood. Also, the figure shows the reinforcement components and shows the improvement percentages as a result of each test. From the figure also, strengthening timber member structural elements or members using composite material is not only limited to reinforce in new members, as can be seen in test number 1 to test number 11, but it found to be an optimal solution also to retrofit deteriorated or damaged members at historic buildings and improve their strength properties. The researcher of test number 12 found that reinforcing of deteriorated or damaged structural wood members using fiber reinforcement polymer composite materials reduced significantly the member deflection from 20% to 50%. And the load carrying capacity of the member has improved by 36%, which is a good result. And based on this investigation, the best type of timber to reinforce is engineered timber, as we can see here from the figure, is engineered timber glulam, and the type of installation method is using internal fiber reinforcement polymer pins. However, In this study, the main focus is to reinforce engineered timber that is locally available, okay? And glulam is actually not locally available in Australia, okay? Therefore, the type of timber that is locally available and used in this study is laminated veneer lumber, LVL, and using external reinforcement approach of Europe sheet. This sheet of fiber reinforcement polymer material will be attached to the most stress point in the member, as we can see here. After stage 1 and 2, after finding the best reinforcing material and after finding the best implementation method, now I move to stage number 3. In this stage, a computational parametric study was conducted based on stage number 1 and stage number 2 in order to find the best economic solution to reinforce timber member. A 3-point bending test was conducted on 2,100 millimeter span length using various lengths of Europe sheets that range from 300 to 1,800 millimeter, applied at the tension side of the beam. And as a result, the load deflection curve is this one. The results show that the load deflection, the load carrying capacity of the member is improved with increasing the length of the fiber reinforcement polymer. But after, as we can see here in the figure, after reaching a particular length of fiber reinforcement polymer, there is no significant improvement found in the result. So the first curve is represents the 300 millimeter length of carbon. The second one is the 600. The third one is the 900. The fourth one is the 1200. Then 1500, and then the last one is the 1800. So after reaching the 1200, I have noticed that there is no improvement found in the result. Also, what I investigated also, the stiffness of the beam of each member, of each reinforced member. The stiffness for each member was estimated as shown here in this table, and the result is summarized here. From the table, it can be seen that the stiffness has increased also with increasing the length of fiber reinforcement polymer. And again, after reaching a particular length of fiber, there is no improvement noticed. So instead of wrapping the whole beam or the whole span length, we can only reinforce like 900, okay, and can give us the result, the same result of 1800. So instead of reinforcing with 1800, 900 is enough for a total span length of 2,100, or the total length of the beam is 2,400. And lastly, as a conclusion, this study is, as I said before, is part of research project aiming to accurately determine the influence of using composite material to reinforce timber member. The aim of the present study is limited to the result of the computer modeling. Further research and development of this study will be reported in subsequent publication. Thank you very much, and I'm happy to see your questions.